this video, we're going to take a look at how we can conduct a hypothesis test for a variance for the sample. First, we'll look at the hypothesis test for a variance. Chi-squared can be used to test a variance. In this case, it can be a left-tailed, right-tailed, or two-tailed test, which is different than the prior test we saw with tests for independence and goodness of fit, which were always right-tailed. The way we calculate chi-squared with a variance is we take the sample size minus 1 times the sample variance divided by the population variance. Be very careful here. Notice that sigma squared is the variance of the population, and sigma is the standard deviation of the population. S squared is the variance of the sample, and S is the standard deviation of the sample. The variance is the square of the standard deviation. So we have to be careful with what we've been given in the problem. If we've been given the variance, it's already been squared and we do not need to square again. But if we're given the standard deviation, we'll need to square it in our calculation. The chi-squared also has the degrees of freedom. It's going to be the sample size minus 1. In Excel, we can calculate the areas for our p-values. If it's a left-tail test, we'll use chi-sq.dist, open a parentheses, we'll type in the value of chi-squared, comma, the degrees of freedom, comma, and we'll always say true to get the cumulative probability. For a right-tailed test, it's very similar, but we'll have a .rt at the end, and we no longer need the true. And with a two-tailed test, we have to be careful. We have to choose the correct tail, either the left tail or the right tail, based on our sample. It'll always be the smaller value. And then we double that value to account for the second tail. Let's look at an example where we do one of these. A discount store is interested in if independent checkout lines or single lines impact the variance of checkout times. Historically, the independent lines have had a standard deviation of 7 minutes. Notice that standard deviation of 7 minutes, that is historically for the entire population. That is our sigma. Just sigma because it's standard deviation. A sample of 25 customers, that's our sample size of n, in the single line found a standard deviation of only 5 minutes. That's the sample standard deviation, f. So can the store conclude that the variance has been reduced? Our goal is to see if it has reduced. So our null hypothesis is that the variance, sigma squared, is equal to what the population variance is. Notice we're given the population standard deviation of 7. To change it to a variance, we have to square it to get a variance of 49. The alternate hypothesis is that the variance has reduced. That's what we're trying to show. So it is less than the 49. If we think about our graph then with our chi-squared, starting at 0, we want to be less than 49. So we're going to be in this left tail, less than the 49. So to calculate our chi-squared value, we take our sample size minus 1 times the sample variance divided by the population variance. Sample size is 25, so we have 24 times the sample variance, which is 5 squared, because the standard deviation needs to be squared to make the variance, divided by the population variance, which we already found out was 49. And we end up with our chi-squared value of 12.24. We also know the degrees of freedom are 1 less than the sample size at 24. So let's go to Excel to calculate how much area we have in that right, or in that left tail. I've copied over onto our Excel sheet here that the chi-squared value is 12.24 and the degrees of freedom is 24. So now we can say equals chi-sq.dist, open a parentheses because we want the left tail. We'll type in that chi-squared is 12.24, comma, the degrees of freedom is 24, and we'll always type in true to get our cumulative probability of 0.023. That gives us our p-value of 0.023 is our p-value. And because that is less than our alpha of 0.05, we will reject the null hypothesis. In favor of the alternative, it appears, based on our sample, that the variance has reduced, or specifically the standard deviation has reduced from 7